Hey guys, and welcome back to another video. Today we'll be talking about angle relationships in a circle, or in this case outside. But we're going to talk about how the secants, tangents, and chords, they come together and intersect, and then it creates like these situations where we're able to find the angles within using formulas. So there are two scenarios in this kind. The first one, this one, we have the angle would be outside, like whatever it intersects. But this one, it would either be a secant plus another secant, so two secants, or it would be a secant plus tangent, or it would be two tangents. Is how this line will work. So let's say this one right here, we have two tangents, but if we had like the line here and then maybe here, it would be, this would be a secant and tangent, and yeah, you got it, like, and then that would be two secants. So that's like the kinds of lines you can get in this situation, where you would find this angle that is outside of the circle. So this one is outside, and then this one is inside the circle. So the way you will remember that is by secants and tangents would be together. So secants and tangents can only be on here. And then, so that means that chords is only on this kind. So this would be outside, and then this would be inside. And you'll remember that, and then you'll remember the formula, because the formulas are the same, except they have one different symbol. And now, if we were to talk about this one is two intersecting chords, and then it creates four angles, but technically two, because we see vertical angles here. So it would be two different angles, but four angles in total. But yeah, but it does create the angles on the inside. So yeah, so let's talk about this one first. So this one here, the formula would be, we would have measure angle 1, which this is measure angle 1. So the missing angle would equal to 1/2 times x subtracted by y. So basically this right here, these are the arcs. We use the arcs to find out the angles, because that is what we're gonna be given. So we can color code this. X is yellow and y is gonna be orange. So obviously the bigger number goes first. So this part of the arc would be y, or sorry, would be x. So let's say it's 280. So it would be 280 subtracted by the y section of the arc. So it would fill up the whole circle since the arc is there. And 280 subtracted by 80, let's say. And then we would multiply that by 1/2, which is the same thing as dividing it by 2, because you're multiplying it by 0.5. So 200 divided by 2 is 100. So the measure of the angle would be 200 times 1, and then 100 degrees. But obviously this right here is not proportional. I just drew it, you know. So yeah, that is how you would do this kind.
You ever had a dream that you
So moving on to the next one, here we have the ones formed by chords and inside of the circle. So angles formed by two intersecting chords inside of a circle. And so the measure of the angle formed by the two lines that intersect inside the circle would be half the sum of the measure. So this one, basically the same formula, but as we can see, I said sum. So inside the parentheses, it wouldn't be a subtraction sign, it would be an addition sign. So what we have here, so what we use on this one is, we're gonna use these two arcs. We're gonna use the arcs that are across from the angles we're using in our formula. And then this arc right there. So we can name this one y, and this one over here x. So the formula would be, these two angles would be both measure angle 1 because they're going to be the same. They're going to be the same degrees since they're vertical angles. So they're both measure angle 1. So the formula is measure angle 1, or the measure missing angle, whatever, equals 1/2 times x plus y. So yeah, it is the same thing as the other circle we just did, except it's an addition sign. And you can remember that by the two intersecting chords form basically kind of an addition sign in the middle of the circle. So basically it forms an addition sign inside the circle. And so you would remember that this formula, this theorem, uses addition and not subtraction. And if you remember this, then if you know that since this is an addition sign on the inside, then the other one, which is the angle outside the circle, would be subtraction. So yeah, x and y here. So let's say x is 90 and y can be 40. 90 plus 40 equals 130. And then 130 divided by 2 equals 65. So this degree would be 65 degrees, and both sides would be 65 degrees since they're vertical angles. Then you can find this angle right here by subtracting 180, 115, since it's a straight line. So then you know that this angle, these two angles would be supplementary to each other. So then it would be 180. So that is how you do these two. And I will write the formula more clearly up here. So that is how you do those two kinds of intersecting secants, tangents, and chords in a circle, and how you can solve the missing angles. I think I will have a video on solving the missing lengths of the chords, secants, and tangents on a circle. But this video is supposed to be solving the missing angles with intersecting secant, tangents, and chords. So yeah.